Hi everyone, welcome back. Today we are building a frequency indicator circuit that visually shows the frequency level of an input signal using a 10 LED display. No microcontroller, no digital display, just two classic ICs, the NE555 Timer and the LM3914 Display Driver. This circuit gives an approximate frequency indication across a range of 10 Hz to 6 kHz. Let's build and understand this circuit step by step.
The circuit runs on a 9-volt battery. The input signal passes through capacitor C4 and diode D11, shaping it into a clean trigger spike. Resistors R7 and R8 set the correct biasing level. This spike reaches the base of transistor Q1, 2N2222, which switches on and off with every input cycle, repeatedly triggering the NE555 timer in monostable mode. Each trigger produces one fixed width output pulse. Higher frequency means more pulses per second, and more pulses mean a higher average DC voltage at the output. Resistor R4 and capacitor C2 smooth these pulses into a steady DC voltage, proportional to the input frequency. This voltage feeds into pin 5 of the LM3914. Now, the LM3914 is operating in dot mode. Pin 9 is left floating. In this mode, only one LED glows at a time. As the frequency increases from 10 Hz towards 6 kHz, the glowing dot moves upward, from LED 1 all the way to LED 10. As frequency drops, the dot moves back down. So each LED roughly represents one step in the approximate 10 Hz to 6 kHz range, giving a quick visual feel of where your signal frequency stands. It's a clean, simple, and elegant way to visualize frequency.
So that's how this frequency indicator circuit works. One glowing LED moving across 10 positions to indicate your approximate frequency between 10 Hz and 6 kHz. If you found this helpful, please like, subscribe, and hit the bell icon for more projects. Thank you for watching.